Hey there! Welcome to today's video where we'll tackle a common problem that developers face when parallelizing code in CUDA. The problem we have at hand involves a C++ code with a variable length inner loop that depends on values obtained from the outer loop. This makes it tricky to effectively parallelize the code using threads, especially for very large arrays. Now, let's dive into the solution provided for this problem. The key idea is to have each thread compute one element of array B by scanning all elements of array A. Each thread is assigned a specific index in B, and then iterates through A to determine if the current element falls within the required range. If it does, the thread updates the corresponding element in B using a specific formula. This approach ensures that each thread handles a portion of the computation, making use of the caching of A and minimizing divergence among threads. Building upon the initial solution, a further optimization technique involves preparing a histogram or similar data structure for the inputs. By utilizing histogram ID values, we can efficiently map elements to their corresponding targets in B. This method essentially involves iterating through all elements of B, checking if the current element falls within the range specified by elements in A, and setting the value accordingly. By accessing the elements of A uniformly, we can optimize the performance of this collision detection algorithm. In summary, we've explored a clever approach to parallelizing a C++ code with variable length loops in CUDA. By assigning each thread a specific task and optimizing the access patterns, we can efficiently compute the elements of array B. I hope you found this video helpful. Don't forget to subscribe, like, and leave a comment below. Stay tuned for more coding tips and tricks. See you next time.